The fastest Claude request is the one that doesn't reprocess yesterday's context. Modern Claude apps repeat system prompts, tool schemas, examples, product rules, and retrieve documents. Across thousands of calls, this repetition is costly. Prompt caching turns repetition into infrastructure leverage. Stable context becomes reusable state. Teams spend tokens on fresh work, not reprocessing the same foundation. Cost control becomes part of product design. The core limitation isn't just model intelligence, it's the repeated pre-fill process. Every request makes Claude read the prompt first. When 90% of the prompt stays the same, the app still feels slow and expensive. Naive trimming helps a little, but it often removes key instructions. It also strips away examples and evidence. Reliability depends heavily on these elements. A production prompt usually has two zones. The stable zone holds tools, policies, and examples. It also includes product knowledge and long reference material. The volatile zone contains the latest user turn. It includes retrieved snippets and output constraints. Without caching, both zones are billed repeatedly. They are also processed over and over again. The fix starts by separating durable context from per request intent before optimization. The diagram should clearly show that boundary. Prompt caching checks if a prompt prefix exists from a recent request. If the prefix is found, Claude reuses the process version. If not, it processes and caches the full prefix when the response starts. Cache the part that stays the same, then append the part that changes. Caching isn't free, but the economics are asymmetric. A 5-minute cache write costs 1.25 times the base input price. A 1-hour cache write costs 2 times the base price. Cache reads cost only 0.1 times the base input price, so the 5-minute cache can pay off after just one reuse. Longer TTLs require more deliberate traffic patterns to be effective. Claude caches the full prefix in a defined hierarchy. Tools come first, then system, then messages. That order makes architecture matter. Put stable tool definitions and system instructions early. Keep user-specific volatility later in the sequence. Avoid rewriting top-level instructions midstream. A tiny edit near the front can invalidate everything after it. This turns an optimized path back into cold start behavior. Automatic caching is the default for most teams. Add cache control at the top level to start. The system moves the breakpoint forward as conversations grow. Explicit breakpoints offer surgical control. Cache system prompts, policy packs, tool schemas, or long documents independently. Start with automatic caching. Graduate to explicit when reuse becomes predictable. Each mode supports a different reliability posture. Design the request like a memory lane. First, identify stable context. Second, place cache boundaries after large reusable blocks. Third, keep volatile user input after the cached prefix. Fourth, keep tool results after the cached prefix. Fifth, keep final formatting instructions after the cached prefix. Measure cache creation input tokens. Measure cache read input tokens. Measure total input tokens. Optimization becomes observable, not mystical. Every request shows what was reused. Every request shows what was wasted. Cache misses often stem from small inconsistencies. Changing tool chished can trigger a cache miss. Inserting images may invalidate the cache. Moving cache markers disrupts cached content. Editing cache text forces a new entry. Missing the TTL window causes refetching. The real enemy isn't complexity, it's accidental mutation. Treat cached context like a versioned artifact. Stability is a performance feature, not just a prompt writing habit. High latency applications shouldn't wait for the first user. Cache pre-warming loads shared system prompts early. It uses max toggles set to 0 for efficiency. The result is immediate response times. First token time feels intentional, not sluggish. The heavy prefix is already prepared in advance. Prompt caching changes how teams design Claude applications. Support copilots can hold policy manuals without reloading. Coding agents keep repository maps stable across turns. RAG systems reuse instruction scaffolds while swapping evidence. The app becomes cheaper, faster, and more consistent. Context is engineered instead of dumped in every call. Reliability improves as repeated context stops drifting. The mature Claude stack treats context like an OS resource. Stable memory, retrieve knowledge, tool contracts, and intent flow separately. Each has explicit lifetimes for clarity and efficiency. Prompt caching next prompt crafting to context engineering. The new skill isn't asking Claude more, it's deciding what Claude should never have to reread.